Hi, my name's Ian Henry, and I just wanted to share with you a demo I have created in SAP Analytics Cloud using the HANA anonymization features. So I'm in Analytics Cloud now, and we can see this first tab is looking at the data masking feature. So on the left side here, we are seeing the raw data, the unmasked data, if you like. And there's potentially some sensitive information. We specified that being the telephone number and the social security number. So on the right hand side here, we've applied the masking to both of those fields, chosen our character we want to replace, and the replacement field being the hash. So we can now see telephone numbers keeping the country code. So different lengths of country code are still preserved, and then we're masking the middle digits and then keeping the last two digits. And then for the social security number, we're just masking the middle part of those numbers. So you can see how that's done. Quite a easy way to do that. Often you may want to do that with things like credit card numbers as well. Anytime you've got some sensitive information that you don't want everybody to see, we could use the masking. Okay, to the next anonymization or privacy feature is what we call differential privacy. And with this one, what we actually do is introduce some noise into the data. So we're not actually exposing the real information, we expose a different version of that. Now in this visualization, I'm showing both of them so you can see the difference, see where that noise has come from. So here we can see the total salary, and even compare that to the differential privacy version, to where the noise has been added, and we can see there's only a 2% difference. So still kind of statistically relevant information, but potentially protecting the raw information. So whether that's salary or whether that could be an expense claim or any other information where the exact number could be sensitive. Now I've also applied that privacy and related to that to a hierarchy. So it's applied to the base data, but we're aggregating up the hierarchy so we can see exactly where in the hierarchy those differences are. So sometimes it'll be higher, sometimes it'll be lower, and then we can just see exactly the differences as we look down the hierarchy. So again, if you look down, the numbers are normally very small variance between the actual and the differential privacy, but they're all there available to see just to understand what's happening. Okay, so the next feature I'm going to talk about is what we call k-anonymity. And here we've got a number of visualizations that include that feature. So again, on the left hand side, this is the raw data. So we can see on the global level, we've got 50 employees, average salary, and if you look across the board, that is the same throughout. So we'll have one copy of the data, and then we are applying these anonymization rules to that. Now on the right hand side here in the middle, we've got k defined as 3, so we're saying anything when k is less than 3, so the number of records being less than 3, we are not allowed to show that information, so we need to do something to that. So here we've just applied this anonymity or anonymization algorithm to the geographic, what we call the site. So it's just applied on that one dimension. And if we look down the data, we can see drilling down, obviously the employee count's going down. We're getting to see the average salaries. If we go into Canada, we can see Toronto. There's a potential security or privacy violation if that number is required to be at least 3. In reality, it could be a lot higher than 3, but that's the threshold I set for this demo. But if we look into USA, we have got the 3 people, so those would be allowed to be shown. But here we've only got 2, so that one does violate our privacy rules that we set up. Now this is the base data, so obviously there is no privacy applied. The data, it's kind of what you see is what you get. Now on this side we've applied what's called the strict anonymization, where you have defined K as 3. So let's drill down into North America and to Canada, and now we don't see the sites, the lower levels. So Toronto and Vancouver are now removed. They're pushed up to Canada, because there's now 5 people in there. It's okay to show that. Now actually, if I look into the USA, it's also been aggregated up, because this is what we call strict anonymization. So anywhere where that rule is violated, we then do it across the board. So even when it was okay to show that. So that's probably good in some scenarios. However, there may be scenarios where people want to look at a more relaxed approach, which is what we've defined here. So we drill down into these again. You can see in Canada, again, we've lost the lower level of detail. But if we go into the USA, where we have got 3 employees, we're allowed to show that information. So now we get into that that detail still retained. So again, a different strategy that allows some data to be retained. Now, in reality, it's not just one field here we've defined as being sensitive, what we call the quasi-identifiers. There could be many fields. So to show you on the grid how that could look in reality. So if you look start on the right hand side this time, we can see we've got age, site and gender all are quasi-identifiers, and we've again defined K as 3. So within this data set, we can see within Canada there actually are 3 female employees of age 23, so that's okay. But other places we had to aggregate up onto age bands and different places on the geographic hierarchy as well, depending on what data is available. Now on the middle piece, we see much more strict anonymization. So we've lost all the site information, we've just retained some age bands and the genders. So that's to enforce that rule. And obviously on the left hand side here, we are seeing our base data. If you wanted to look at individual records, we can see this record 29 ID is the female in Vancouver, and you can see that record would also exist in this table here, but now we've lost the information. So you just know that the age band is 2024. We know it's female. You see the salary there, but you wouldn't actually know who that was. And over here, that's grouped within these 3 individuals into that that grouping there. So that kind of shows you how the anonymization works. Now, could also show you behind the scenes kind of what's happening in HANA. So this is obviously, these are all built on a live HANA calculation view, and what we've got behind the scenes is some anonymization views. And if we look at one of those, let's look at maybe the relaxed one here. We can see the definition. So we define kind of the name, choosing which of the fields we want to expose, and then you're saying which algorithm we're using. So we're using k-anonymity, and here the relaxed approach is where you say K is 3, but we recode it based upon the dimensions. We define our ID column, so that's the sequence, and then these are the quasi-identifiers, these 3 fields here. So the first one, site, we are using a hierarchy view, so that's providing us the hierarchy, the geographic hierarchy to go up. Gender, we're saying the hierarchy is embedded, but there isn't actually a hierarchy really, because female and male, there's no way to go up into a higher level there, a generalization. And for age, we've actually written a function to do the age grouping, so we can put the age bands in there. We don't have to have it in the data. There's a function just to group ages into 5-year buckets, 10 years, 20 years, as required to fulfill those privacy restrictions. If you wanted to look at this, the output of this, we could go to our DB Explorer, and then we could see views, and then if we look at the relaxed view here, you can then see how that data looks behind the scenes. So it will be the same data we saw in SAP Analytics Cloud. We're just seeing the raw table here. Likewise, we also built some calculation views. So for the differential privacy, for instance, we had a simple calculation view, bringing in that base view, joining that data to our hierarchy. Here we have to use the outer join, and then push that data for consumption at the top level. So fairly straightforward what we did, and then we built the SAC stories on top of that.